Practically everyone understands the importance of photosynthesis, a chemical process that captures atmospheric carbon dioxide and solar energy and transforms them into sugars that plants and animals can use for food or for structures like wood. Fewer people recognize the equal importance of a process done by a few bacteria that captures atmospheric nitrogen and turns it into forms of nitrogen and nitrogen-containing compounds that can be used by plants and animals as building blocks in DNA and in protein. Even though nitrogen makes up 80% of the Earth's atmosphere, these nitrogen-containing compounds with accessible nitrogen are relatively scarce. So scarce, in fact, that even at the height of the British Empire, Britain was forced to import sodium nitrate from as far away as the Atacama Desert in Chile to satisfy its need for fertilizer. But by the early 20th century, food wasn't the only use Britain had for Chilean nitrates. The explosive filler used in British and German shells during World War I contained either picric acid or TNT, both of which use nitric acid from nitrates in their synthesis. Through naval superiority, Britain could guarantee their access to natural nitrates while denying the same to Germany. This means that Germany could have run out of munitions as early as 1915, ending the war 3 years earlier than it did. And this would have happened if it weren't for German chemists Fritz Haber and Karl Bosch, who developed a new method to produce ammonia from atmospheric nitrogen. We can write the chemical reaction for the Haber-Bosch process as N2 plus H2 turn into NH3 to show that nitrogen and hydrogen gas reactants combine to become the ammonia product. To make it a chemical equation, the two sides of the arrow have to equate. We want to show a chemical transformation. That means that we need the same number and the same type of atoms on both sides of the arrow, because these are, after all, the same atoms, just rearranged. So the balanced chemical equation becomes N2 plus 3H2 converts into 2NH3. We can practice balancing chemical equations by following all the steps that take us from ammonia to TNT. Explosives manufacturing wasn't the German army's only application of chemistry in World War I. There was at least one other major innovation. Or at least they thought it was an innovation. The same technology may have been in use 23 centuries earlier. And we'll explore that idea in the next video.